Year 9, question set number 9. As always, you've got 5 minutes to do this. Notice on the first one that we're doing a probability tree for taking some counters out of a bag, but this is without replacement. So just a bit of a hint, the number of counters in the bag will be different on the second time through. The second counter you pick out, the probabilities are going to be different. And then another frequency tree for you. Okay, right, you've got 5 minutes. Have a go at everything, please. Off you go. Cool, 5 minutes is up, so let's do some corrections. And it's really important that we do these corrections. We're listening to the solution to this. We're not just sort of going, oh, got it wrong, never mind. Do actually follow and do some corrections on your written work, please. Right, so our bag contains 4 blue and 6 red counters, right? So there are 4 blue. Let's get some color on this. And 6 red. Okay, so let's mark up our little probability tree. We need branches for reds, and we need branches for blues. And let's do, so the first time I take, let's take, this set of branches is the first counter I take out, and there are 4 blue and 6 red. That's a total of 10. So the probability of getting a blue is 4 out of 10. Now I could simplify that fraction, but actually that's going to complicate things. When we're doing probabilities, usually we don't, unless it asks us to, we don't simplify our fractions. Just keep them as they are. Makes things a bit easier. Then red. So there are 6 red, so that would be 6 out of 10. Now I'm hoping we got all that right, because that should be fine. Because then we move on to our second set of probabilities. And I'm going to do this top set of branches first. Now, to get to this top set of branches, I must have selected a blue counter. So there's actually now 1 less blue counter. If I've come up this set of branches, or that branch there, I've now got 3 blue because I've already taken 1 out and it's not replaced. So there's now actually a total of 9 counters. So out of 9, 3 of them are blue. So the probability of picking another blue after the first one is 3 out of 9. Now the red counters we can see haven't changed. If I get up to this set of branches, I picked a blue out. So there's actually still 6 red. So at that point, probability of picking a red out is still 6 out of, well, there are 9 counters. And again, notice 3/9, 6/9, that adds up to 9/9, equivalent to 1. Okay, so that's the top set of branches. Let's reset things and imagine that, well, that didn't happen. What actually happened was that, let's go red. Actually, I came down this branch. Let's say the first time I selected a red. Well, in that case, there would be 1 less red. There's now 5 reds. And I'm onto these set of branches for my second counter I'm going to pick out. So if I picked out a red the first time, probability of getting a second red would be 5, because there are now 5 red counters out of a total of 9 again, because, I've picked a counter out. There's now only 9 in there because they were not replaced. Thinking of the probability of picking a red and then a blue, well, there's still, in that case, there would still be 4 blues, but again, there's 1 less counter, so it's out of 9. 4/9, 5/9 makes a total of 9/9. Okay, cool. So that is a sort of probability without replacement. It's conditional probability. The second set of probabilities is conditional on what happened when you pulled out the first counter. Okay, B, calculate the probability of selecting the same colour. Now there are 2 paths to getting the same colour. Either blue, blue, so that path that ends there, or red, red, that path that ends down there. And when you're coming along the branches, you multiply your probabilities together. So the probability of getting blue and blue is equal to, that should be a bracket there, 4/10 times by 3/9. Multiplying fractions, multiply the tops, that's 12, multiply the bottoms, 90. And again, don't simplify, because it'll be easier to add some fractions in a second if we don't. Then the other path was this one where I got 2 reds, because there are 2 ways of getting the same colour. And the 2 probabilities for that would be 6/10 for the first red and 5/9 for the second red. And as I'm coming along the branches, we're doing this red, and is times in probability. So 6/10 times 5/9, so 30. Oh, that's not 36, that's 30. Oops. Over 90. Again, multiply the tops, multiply the bottoms. Now the probability of the same colour, I need to get those two probabilities and add them together. So the probability will be 42 out of 90. Because 12 90ths, 30 90ths makes a total of 42 90ths. Yeah, so when you're going along the branches, you multiply. If you need more than one probability together, like here, you add them together. Cool. Right, frequency tree. 80 children sat a test. There they are, 80. 36 of the children are girls. Okay, so we got 36 are girls. Now we know these frequency trees, if branches come out of an original branch, together they need to make up that total. So if I do 80, take away 36, I'm left with 44. So 44 must be boys, because those two together make 80. 9 out of 80 children failed the test. Now, be careful here, because that's just not 9 in this bubble, because that particular one has failed, and so is that. So I know that those two bubbles will add up together to make 9. Alright, so I'll come to that in a second. 39 of the boys passed the test. Okay, well that's cool, that's straightforward. Boys that passed, 39. Now I know that adds up to 44, so there must be 5 in here to make it add up to 44. And using that bit of information I had before, I know that this failed box or lozenge and this failed lozenge circle adds up to 9. So that must be 4, because 5 and 4 makes the total of 9 people that failed. And of course we know that these two bubbles here add up to this one. So that must be 32. Okay, and just for a bit of neatness, I'm going to get rid of these marks that I put over here. There we go, there's my frequency tree. Remember, frequency trees, they're not like probability trees. They don't show probabilities, they just show frequency. And frequency is another way of saying how many, if this would actually write. There we go, how many. It's just what frequency is another word for in this particular context. Okay, off to do the main task then. And today, you really, really need to concentrate and maybe rewind and watch again. It can be tricky if you're not paying attention. All right, don't skimp it. You've got to pay attention. All right, okay, off you go. Bye-bye.